Okay, let's get started. We're at the end of week 3. So here, wait, before we get started, I always like to, yeah, we don't have time for this today, darn. We'll do it super fast. I don't want to have to edit though, shoot. Here's the numbers real quick. Look at this, people. The market just opened 2 minutes ago. It's up 1/3% already. Numbers were supposed to come out this morning about how the economy ended the year as far as growth is concerned on an annual rate. Looks like the numbers said that the last quarter of 2023, the economy was growing at an annual rate of 3.3. Don't forget that the Federal Reserve's goal is to try to get our economy growing at a steady 2 to 3% a year. They almost got it, and they did it by raising interest rates. Interest rates are frozen right now. If the economy starts to slow way down, they'll start lowering interest rates to get it back to that 2 to 3% range. The economy, when the Federal Reserve is like the driver of a big boat. Boats don't have brakes. If you guys have ever driven a boat and had to dock it to go get gas or something, it's not the easiest thing because it doesn't have brakes. You gotta slow way down. And maybe as you get close, you can throw it in reverse and do some things, but basically it has no brakes. That's how the economy is. And the Federal Reserve is doing what it can to try to keep us. We, as a society, can handle 2-3% growth because our incomes are growing at 2 to 3%. So we're able to take on this growth of overall prices and the economy growing. But when the economy was growing at 8-9% a couple years ago, our society was having troubles with it. Incomes weren't growing as fast and prices were getting out of control. So that's what's going on. Things are back where they should be. That's the whole point. So that's why you're seeing a little jump in the market today based on those numbers is usually the reaction of what you're seeing. That's about all I want to say. Other than oil's back over $72 a barrel, up at 76 now. I haven't noticed gas prices because I haven't gotten gas in a few days, but are they up a little, anybody? Is gas back up at 3 yet?
No, it's
still under $3. Still under $3. Boy, nobody would believe that. We'll go to 2050 and we'll go, hey, in 2024 gas was under $3. They'll look at us like we were crazy. What? How could that be? 10-year bonds back up over 4%, which is great. Gold is right around 2,000 still. Silver's right around where it's always been. And then we always look at Bitcoin. It's down a little. Usually it was around 42, 43,000. There it is at 40. So there's our numbers for the day. Let me get rid of that. All right, what's coming up? Tuesday, 5 days from today is quiz 1. All right, you'll come in. There's going to be a seating chart up here. You're going to see it. It's going to be right in rows, just like these are in rows. Whoever's in the top right is sitting right there. Whoever's in the top left is sitting back there. That's kind of the way you'll see. I'll draw a little door at the bottom so you can see that door is at the bottom of it as you see it there. There's going to be about, I think it's 7 or 8 in every row. And I put up these folders in between each person so that you aren't tempted to look to the left or the right. It's open book, it's open note, it's open anything off Canvas that I posted, you can download and have ready to go. Now, if for any reason you can't come to class early, you may want to have everything downloaded already on the laptop you're going to use, but if you're going to use one of these computers, you might want to put it on a flash drive. So that when you walk in and you see where you're seated, you just put your flash drive into the computer and you have all the stuff off of Canvas. Or if you come early enough, you get onto Canvas and start downloading everything on the computer you're assigned to sit in front of, if you're going to use one of these computers. You definitely need one computer, either yours or this one, because there's going to be some Excel questions, and you got to enter whatever the Excel equation is into Excel to get a result, because you got to write the equation down and the result on your quiz, not just the equation. So that's why you definitely need a computer, plus all the things you're allowed to use. Now, some of you are taking notes. And notes are allowed as long as you turn them into digital. You can't walk in with any paper to have in front of you except for your book if you have a paper book. That's the only paper you can have in front of you. All your notes that are on paper, start turning into pictures, email them to yourself and have them ready to go so you can look at them while you're taking the quiz. You're going to flip through PowerPoint slides, you're going to flip through answers of the homework that's posted, answers of the in-class, you're going to flip through any of those extra things I'm posting like pictures, and then the pictures of your notes are all going to be available for you. I'm going to send specific typed up instructions to everybody. Look for them most likely Sundays when I'll probably send them out so you know what to expect when you come in. But it's going to be everything I just said out loud. What's allowed, what's not allowed. you know, no phones, your phone's gotta be put away, turned off, or not turned off, but the ringer's gotta be off, put away. Calculator, you can have a calculator, any calculator you want, as long as it doesn't connect to the internet, but I always suggest the calculator on the computers, because the Windows calculator, like here's standard, you don't have enough there for standard, but if you switch it to scientific, everything you need for this class is right there on scientific. You don't have to go to graphic, you don't have to go to programming, data, you don't have to go any of these other ones. Scientific will do everything you need for this class. The square root is that symbol right there. It's the square root with the little square symbol right there. So there's the square root. So if you need a calculator, there it is there, or you can bring your own as long as it doesn't connect to the internet. What else? What would you do to prepare for this quiz? I would go back to the instructions, for example, because each week 1, week 2, week 3's instructions will tell you exactly which PowerPoint slides you should review, which pages from the textbook you should review, and then all the different things I posted. I think that since the quiz, let's say the quiz is gonna be 9 questions, if it is, I would predict 5 or 6 of those would be problems like homework, where you're showing me step by step your work as to how you get to your answer, the setup, the calculations, the answer, showing me everything. The other 3 will be multiple choice questions off either the PowerPoints or the reading from the textbook or something I lectured on, some definition maybe or some term. But so 3 or 4 of the questions would be multiple choice, and 5 or 6 of the questions would be problems like the homework. Does that make sense? I'm guessing the time limit. I've only started writing the quiz, so I don't even have the first problem finished. So I'm guessing 8 or 9, 10 problems, somewhere in there. Time limit will be somewhere around 30, 35, 40, 45 minutes maybe, right in that ballpark. We'll start at about 9:33ish, right around there, and then you hand it in. You hand it to me on your, raise your hand if you have questions. I come to you as you're leaving. You give me your quiz, and you walk out the door, and you're done. You just got to be here on Thursday. Start looking at the stuff I'm going to post the new module information after the quiz. So the quiz on Tuesday night, all the new stuff for week 4 is there. You have homework due for week 4 the following week, so you want to start looking at things.
The homework you have posted right now, it's not due next week, right?
Right, the homework that's posted right now, let's take a look. Yeah, is not due Tuesday. Everyone needs to focus on the quiz and prepare for the quiz. This homework right here, let's see, there's 3 parts of it. Number line assignment, written assignment, Excel assignment, due never. It's the assignment that you have in week 4 that I'll post Tuesday night, that's due a week after that. That's week 4's assignment. The week 3 assignment is not to be handed in. I'm posting the answers tonight. And if I forget, someone please email me tonight if I forget, because my goal is to post the answers to this week 3 assignment tonight. And we're going to talk about this week 3 assignments today a little bit. But we're not turning this in. I would take these answers, have them ready to go for the quiz though, because this is actually the most important assignment of the 3 weeks as far as preparing for the quiz. So I would definitely feel like you know how to do this assignment, all 3 parts of week 3s, because the biggest part of week 3s is the binomial probability. Before we get into the new stuff though, let's keep going with the quiz a little bit, because this is a big deal. This is your first quiz, and I want everybody to do well. Again, to prepare for it, it's a matter of you saying, hey, you could go back and watch the videos and see the main subjects I write on the board. And you could write them all on a piece of paper and then start putting next to them which PowerPoint you'd go to, which slide on that PowerPoint, which homework assignment you would go to, which problem reminds you of expected value, which homework assignment is binomial probability. Each subject I would have where to go, and then when you read a problem, you just need to prepare to be able to recognize what it is you're looking at. Once you recognize it, you look at your list of subjects, you go, oh, I'm going to go to this PowerPoint slide, or I'm going to this homework problem, and that will refresh your memory how to do it. That's how I'd prepare. You had a question, go ahead.
Is the quiz going to be based on today's lecture as well?
Yes. Yeah, probably a big part is on today's lecture. Yeah. So today's an important lecture, so I'm glad a lot of you showed up.
So the week 3 assignment that we sent in was
No, you've sent in so far week 1 and week 2's. Tuesday, you handed in week 2's assignment, which I graded everyone and got it back to you. And then week 3, which would be due Tuesday as you're walking in for the quiz, You're not handing in, you're preparing for the quiz instead. But then there's a week 4 right after the quiz that will be due the following Tuesday, 2 weeks from now. Yeah, okay. So this weekend, instead of doing homework, it's all about preparing for the quiz. The goal is that, this is the quiz that's gonna save your grade. This is the one everybody does their best on. And so don't take it, you know, do it because you need it. You know, I wanna tell you, everybody goes, oh, this class is open book, open no, it's gonna be easy to get an A in this class. I just had to hand in my, you know, I'm going through an evaluation this year, so I had to hand in all my past grades. And I noticed that last semester, each section only had maybe 4 A's. The semester before that, there was only 3 A's. So as you can see, it's not an easy class to get an A in. So so you gotta rely on this first quiz to get an A on it, to keep your grade up, because it gets harder. This class gets harder and the quizzes get harder. The time limit is the hardest part. And that's where you gotta practice. If someone said to me, okay, let's say you got everything organized, everything. Okay, now what would you do next? I would take the homework assignments that I posted without the answers, and I would print them and cut them up. So there'd be, you know, let's say you got 14 homework assignment questions. Then I would fold them up, put them in a hat and mix them up. I would draw one out at random. And I'd look at it and I'd go, okay, how long will it take me to find the help I need to answer this? That would be the practice, and that's how you prepare for this quiz. Is how fast can you find the help you need for some random question you just pulled out of the hat that was really one of our old homework questions. And this quiz is not gonna be a shock or a surprise or stray away from the normal. It's just the time limit's gonna get you if you're not ready. That's the only hassle to it. And you gotta make sure that as we're getting to the end of time, I wanna make sure everybody hears this, you cannot leave an answer blank. You must take a guess. Or if it's a problem, you must pull some numbers out and start adding, subtracting, dividing, and multiplying them any old which way, because I am very generous with partial credit. But if you leave it blank and there's no answer there for me to give partial credit, you tied my hands. It's impossible. You must at least attempt every single question with some way, putting some work there, so I can give you partial credit. All right? Any questions? Are we ready? We are. It's going to be this is it. This is the one. This is the confidence builder quiz. All right, ready for the new stuff? I hope we have time for our in-class. It's a good in-class. It's really going to prepare you, so we got to do it. So someone keep an eye on my time. This class goes 9:30 to 10:45. That means at 10:30, I have to be almost done with this lecture to make sure we have enough time for the in-class, okay? All right, so now, where are we going? Where are we gonna go? Here's the instructions, you know, never do. Just like every instructions, there's the materials. If you say, which PowerPoint should I study? There they are. This one has 2 different chapters of PowerPoints. I hope everybody watched that, the video from Tuesday. I hope everybody watched it, because there's a lot of important stuff on there, especially how to calculate Z. Everybody get that out of the video from Tuesday, how to calculate Z. If you didn't, watch it again. That's the best.
No, on the video.
Oh, on the video, the board, you couldn't see it very well? Yeah. Bummer. I don't know what to do. I'm gonna review a teeny bit, the most important part. Did you hear me?
Yeah.
I'm gonna review the most important part though. Okay, right now, today. D-chart, what else? That's it, week 3 probabilities. We'll talk about that in a minute. All right, so let's go to the number line assignment. Here is this week's number line assignment. Very similar to the last couple weeks. We're coming so close to the end of doing number lines. But you're gonna realize these number lines we've been doing, these crazy number lines, having to add and subtract the standard deviation 3 times, have been the building blocks to prepare for everything that's coming in the future. If you can understand the empirical rule, you know, just being able to throw numbers at me, this probability, that probability, this whole class becomes so much easier. If you can visualize this, it almost is too easy in a way. Let me give you an example. Here is the number line assignment for this week, which you're not handing in, so I have the answer right up there. Who cares, right? And it's the same thing as before. This time you're given a mean and a standard deviation, which is right where my pointer's at. 64.4 is the mean. 9.2 is the standard deviation. This is about apples in a cart. We're gonna randomly look at the next cart coming in. That's 1 sample. We're only doing sample size of 1. And we're gonna look at that next cart coming in and count the apples on it. All right, we're gonna see if there's around, what is it, 6.4 or 64.4 is our mean of how many apples are on each cart. The cart is the sample, and we're only gonna look at one of them. After quiz 1, we're heading eventually to where the sample sizes will be 30, 50, 100. But for the beginning of this semester, we've been focusing on a sample size of 1. All right, the next cart that comes in, we just stopped everything and said the next one, randomly coming in. Here's the numbers if we add and subtract the standard deviation 3 times, and I have them up here on the board. 64.4 going up, 64.4 going down, 9.2. All right, can everybody see these numbers? Because I'm about to make sure we understand the empirical rule, the main part of the empirical rule. The left side of this bell curve and the right side of this bell curve are mirror images of each other. So if I said to you, hey, what's the probability that next cart of apples comes in and there's 55 apples or less? 55 apples or less. Is the answer of the probability of what I just asked for going to be more or less than 50%? Very good. She said less than. Right away, you've got to be able to recognize 55 is so much farther below the mean, and less goes this direction, that it's got to be less than 50%, because right here's the 50%. If I said to you, hey, this next cart's coming in and there's 70 apples on that cart, what's the probability there's going to be 70 apples or more on that cart? Is that answer going to be more or less than 50%?
More.
Less.
No, less. Who said less? Thank you. Why?
Because 70% more.
Look at where the 70 lands on the number line. I fooled you. It is on the right side. I didn't say 70 or less, though. Be careful. I said 70 or more. And 70 or more is less than 50% because it's going this way. So you got to be careful. You got to be careful. You're getting this. All right? You're at a point now, because we know how to use the z-chart and calculate z, that you should be able to calculate the probability, estimate it darn close, because the z-chart's not exact. It's a darn close estimate, though, because we're only going 2 digits to the right of the decimal in our calculations. But you can find the probability of any number between these numbers, 3 standard deviations above or below. You can find the probability of any number or less, or any number or more, by using that z-chart. I want to make sure you get this. This was on Tuesday's recording, and this is the most important part. So we're going to do one. Look at the highest number I have here is a 92. The lowest, we'll call that 37. 92 and 37. Pick a number between 92 and 37 right off the top of your head, whatever feels good. It's 26. Is that not between 37 and 92? She's out. She's out. Go to handicap parking. Next, give me a number between
54.
30. What is it?
54.
54. That's as easy as that. Here's the formula. The number being asked the probability of. The question's going to say, what's the probability that the next cart of apples has 54 apples or less? The question is 54 or less. Let's look at the number line. Look where 54 lands. I see it kind of like right there. I kind of see it about, just right around that area. I'll put a bunch of little dots because I don't know exactly where it's at. But 54 or less. My question for you is, when I calculate this, should my result be more than or less than 50%?
Less.
Less, very good. Less, because that is to the left of center, and I said or less, so it's going to the left, so it's got to be less than 50%. Right there should be a good indication. Matter of fact, look how far left of center we are. Look how much space there. That is so far over, past even 1 standard deviation, that from the empirical rule, we would know exactly from 1 standard to -1 over. And this is just left of that. So we'd be able to be darn close to guessing this if we knew exactly what each of the numbers were in the empirical rule. So here's how we're going to manually calculate it. We're going to manually calculate it just like this. But in this case, we were asked about 63. In this case, we're being asked about 54, but it's the same process. This is the example I have right in front of me when I see a question asking me to calculate z and find a probability. And here is the example. It's taking the number being asked about, subtracting the mean. We're doing the same thing. The number being asked about minus the mean. 54 minus 64.4. Parentheses. Someone who loves numbers and finds this easy, grab a calculator and get ready to help me. Now, the denominator is supposed to be divided by the standard deviation over the square root of the sample size. But the sample size is 1. So the square root of 1 is 1. The standard deviation divided by 1 is the standard deviation, so that's all we got to use right now since our samples are all 1. Standard deviation, I forgot what it is. 9.2? 9.2. So this equals, this is, first of all, you ready? Are we using the positive or the negative z-chart?
Negative.
Negative. Because anytime the number being asked about is to the left of the mean, we're using the negative z-chart. Anytime the number being asked about is to the right of the mean, we're using the positive z-chart. You got it. All right, so 54 minus 64.4, hang on a minute, that's like 10.4, negative 10.4? Negative 10.4 over 9.2, this equals a negative 1.113?
1.3.
1.3.
Yeah.
What's the number after 3? Just I want to check this out.
Zero.
Zero? Oh, very good. All right, there's our z. It's right there. There's the negative 1. I said it's just to the left of negative 1, and sure enough, it's negative 1.13. It's just to the left. Go ahead.
How did we get 9.2?
9.2 was given in the problem. It said the standard deviation is 9.2 right here, and the mean was 64.4, also given.
So we always subtracted by the mean.
It's always subtracted by the mean. So it's whatever you're being asked the probability of minus the mean, parentheses, because you got to do the subtracting before you divide, divided by the standard deviation. There will eventually be the standard deviation over the sample, the square root of the sample size, but right now it's just the standard deviation for this first quiz.
So that's the feature.
I'm sorry?
That's the answer.
This is the answer for z. That's the answer for z. We just calculated z. This is our work to find z. But look at the next step. This case, when we were doing 63 or less, the z was, what does it say, negative 0.15217. Then we used the negative z-chart. This problem was asking you to announce which z-chart you're using, but I already asked you. I said, which z-chart we're using, negative or positive? You guys said negative. So we're going to use the negative z-chart. We're going to look up negative 1.13, and that's the probability from 54 or less. That's how we do these problems. So let's look it up. Here we go. This it? No, that's not it. Where's the z-chart? This is it. That's the positive. We gotta go up here to the negative. There's the negative. The first digit to the left and the first digit to the right is in this first column, and ours is 1.1. So I'm going to the negative 1.1, just to the right of my pointer right there. The next digit is a 3, so I'm going to the column 0.03. So I'm going over, here we go, right there, 0.1292. 0.1292. There's your answer. You can leave it just like that. There's your answer. You can leave it just like that. If you're saying this is easy to me, move the decimal 2 places, add a percent symbol then. That's up to you. If you find this easy, do it. But leave in this decimal if you're not finding it easy. Once you looked it up, there's the answer I'm looking for.
Can you do exactly where the difference in the sample is not one?
No. The sample size is only 1 for this first quiz, not until this quiz is over with. I don't want to confuse anyone. The sample size will always be 1 for this first quiz. So you know you're only using the standard deviation in the denominator. Go ahead.
In Tuesday's lecture, you subtracted one of the numbers by 1.
Yes, we're about to do that.
Oh, okay.
If it's a more than. Go ahead.
Are we getting the sheet on the quiz?
This?
Yeah.
You gotta download it. I posted it twice on Canvas. This is one of the things you're downloading.
Okay.
Yeah, all the stuff on Canvas I posted. You know how you go to those home and you have all those modules? All those things, those modules, get those downloaded. Yeah. But here, they're asking the same question. You guys are jumping ahead. Here we go. They're asking about what happens if this were a more than, all right? You ready? Now I'm switching this to 54 or more. Guess what? We would do it the exact same way. The only difference is one additional step, and that's to find the opposite of what you just calculated off the z-chart. Just whatever, 100% minus that, or 1 minus that. So here we go. 1.0 minus 0.1292 equals the probability for 54 or more. You've got to find the opposite of what you just looked up on the z-chart. What you're looking up on the z-chart is answering every question or less. Doing this last step as if it's or more. Now I want to teach you a trick. Don't do this. This is those who really are getting this. The rest of you just plug yours for a second. I don't have time to subtract this, so I just find all I gotta do is look this up on the positive Z chart and it gives me the opposite. So I don't have to calculate it. It's a little trick. Hang on, I'm just going to see, I'm just gonna go and check, so I don't have to subtract those, I just go to negative, a positive 1.3, there it is, 0.87, 0.8708, is that what it says?
Yeah.
Yeah, so, there, I cheated, hang on, let me go back. Don't do that though. Whatever you do, don't do that, just, you always are looking up to the left, something or less, and then if it's more than, subtract it from 1, find the opposite. Yes?
Can you do it again?
Well, no, that trick? No. No, that's the whole point. The whole point is I don't want you to learn that trick. I want you to take your calculator and put 1.0 minus 0.1292.
Wait, wouldn't you need the work though?
What work? You mean,
Like,
if you wrote this down, whether you enter that in your calculator or you do my little trick, you're still gonna get the same answer.
but you still have to do the work for the exam. Like,
Oh,
you have
this
to-
work right here?
No, like the 1 minus the.
You gotta show 1 minus if it's more than, yes. You gotta write down 1
Even
minus.
if you go find it. in the
You have to
calculator.
look it up and then put 1 minus of what you just looked up, yes. See what she's asking? She's asking, once she realizes this is a more than, she's saying, I just calculated a negative, can I go straight and look up the positive? I'm saying, no, you gotta look up the negative and then put 1 minus, and then get the answer. Show me that you can do it the right way, and then we'll do shortcuts later. All right, there you go. There's that part. All right, so now, let's see. We gotta go to this. Let me see how we might do that so fast. Okay, these are what I call simple probabilities. Everybody see these probabilities? This is, we went back and looked at the history of a realtor who sells houses, and here's the number of houses. And we went back many months and we counted how many houses this person sold every month, and we found out, and then we took them all. You know how to put together this relative frequency table. This realtor, 30% of the time, sells 0 houses in a month. 50% of the time sells 1 house, 15% of the time sells 2, and 5% of the time sells 3. Never sold more than 3, so we're just going with these numbers right here. Now, I'm gonna ask you some questions. This is called simple probability. You look at those probabilities and you should be able to answer the question and show on paper what numbers you use to get to the answer you're about to tell me. Are you ready? What's the probability the realtor does not sell any houses in the next month coming? What percent? 30%. He got that by looking up there. He said, oh, selling no houses is the same as selling 0, so that'd be 30%. What's the probability the realtor sells at most 1 house in the next 1 month period? At most 1 house.
50%.
80. At most 1 means
More.
1 or less. At most 1 could sell 0 or 1. So you got to add the 2 together, which would be 50 plus 30. All right. You know what? I'm gonna read these. Now I'm gonna start making some up. What's the probability that next month the realtor sells 2 or more houses?
20%.
Very good, 20%. You gotta add the 15 plus the 5. 2 or more would mean the 2 and the 3. So you gotta hear or read what's being asked and then match the numbers up and show me which numbers you're adding together. That's the work you gotta show me. What's the probability the realtor will sell no more than 2 houses? 95%. No more than 2 houses would be 0, 1, and 2, right?
Yep.
So you gotta add those together, which would be 95. You're getting it.
But the one before,
Want to do it again?
the one you said, 20%, I don't understand.
Can't remember what I said though.
No.
Oh, 2 or more? What's the?
2 or more?
2 or more.
Okay, I got it.
Okay. Or at least 2. How about that? At least 2 would be the same as 2 or more, right? Because at least 2. What's the probability the realtor will sell at least 1 house? 70. 70. At least 1 house, you gotta add the 1, the 2, and the 3, which would be 50 plus 15 plus 5, make 70. You get it? So that's called simple probabilities. There's that. Now, we gotta go to expected value. I'm on PowerPoint chapter 5, I'm on slide 8 right now. I want to refresh your memory about this particular problem that we talked about a little bit about a week ago, I think, maybe it was week 1. But This store sells appliances and TVs, like an ABC warehouse. I always think of ABC warehouse when I think of this. And in the past, they only at the most can sell 4 TVs. That's the most they have of every TV available. So or TVs, period. It's a small place. So most they can sell is 4. They went ahead and went back and said, we're gonna look at the last 200 days that we were open and count each day how many TVs we sold, and then turn it into a frequency table. And there it is, 80 days of the 200 we sold 0. 50 days of the 200 we sold 1, and so on. Turn it into a relative frequency table. Here we go. 80 days divided by 200 is 40%, 0 TV sold. 50 days divided by 200, 25%, 1 TV sold, and so on and so on. Everybody see how this table's made, right? Now, normally, if I said to you, what is the mean of this data, you would just add up 0, 1, 2, 3, 4, and divide by 5, because there's 5 numbers there. But this is called weighted data, because there's probabilities with it. So let me show you here. Hang on, let me get to this slide. There's the probabilities again, and there's the numbers. 0 TVs, 1, 2, 3, 4, 40%, 25%, 20, 5%, and 10. There's the relative frequency table. To find the mean, which is called expected value when there's weights involved, you don't add them up and divide by 5, you multiply each piece of data by its weight, then add the results. That's doing the same thing as dividing, but you're not dividing. Let me show you. 0 times 40% equals 0. 1 times 0.25 or 25% is 0.25. 2 times 0.2 is 0.4. 3 times 0.05 is 0.15. 4 times 0.10 is 0.40. Now you add those results, you found the mean of this data called the expected value. Let me repeat that. Expected value and the mean are the same thing. The mean is if you're finding the average of regular data. Expected value is if you're finding the average of weighted data that have probabilities with the data. Let me show you on the homework also. Where is that? Is that this one? Yeah. Let me go up here. Right there on the homework are 3 pieces of data, 21, 18, 24, but there are weights next to it. The weights always add up to 100%. 15 plus 45 plus 40, 1.0, 100%. This is what a problem looks like on the quiz. And you may be asked to find the expected value. You would take, what is that, 21 times 0.15, get the result. 18 times 0.45, get the result. 24 times 0.40, get the result. Add those 3 results, you got the expected value, 20.85.
That's it?
That's it. You just gotta add those results, those three multiplications you got.
Are we gonna have to get X of X from anywhere?
No, I'm gonna give you these X's, and I'm gonna give you these weights. You just gotta do the multiplying, just like I'm doing down here. 21 times 0.5, 18 times 0.45, 24 times 0.4, add the results, there it is, expected value.
How do we know when we have to multiply and not to multiply?
Because when I'm giving you the data with weights with them, that's how you know that you're gonna be using expected value, which is just finding the mean using the weights. But what if there are no weights there? Like put your hand and block the weights. All you see is 21, 18, 24, and I said find the mean of that data. You would add those 3 numbers and divide by 3 because there's no weights there, get it?
Yeah.
Yeah, so you've gotta say, are there weights there or not? Now, we gotta take this a step farther. We gotta find, once we have that 1.2, that expected value using those weights, we have to find the variance in the standard deviation weighted data. It's very similar to the standard deviation and variance we did on the previous homework, but this time there's weights. So here it goes. We now know the mean, expected value is 1.2. I'm calling it mean just so you realize what we're doing. We took each piece of data, subtracted 1.2. 0, minus, pretend there's a column here with minus 1.2 all the way down. Minus 1.2, minus 1.2, minus 1.2. 0 minus 1.2, negative 1.2. 1 minus 1.2, negative 0.2. 2 minus 1.2, 3 minus 1.2, 4 minus 1.2. Just like we did previously with the raw data, we subtracted the mean from each number. Next, we take those results and square them, just like we did previously on the variance. Square to get rid of the negatives. Negative 1.2 squared. Whoa, I'm moving the whole thing, didn't mean to. Negative 1.2 squared, 1.44. Negative 0.2 squared, 0.04. 0.8 squared, 1.8 squared, 2.8 squared. Just like we did last time. Now last time, you would add these squares up and divide by the number in the sample minus 1. Everybody remember that? But not with weights. If there's weights involved, you do not add these up. You do not divide by anything. You multiply each result, each of those squares, by the corresponding weights. Since 0 had an original weight, let me go back to the original weight. 0 had an original weight of 40%. You take the result times 40%. 1.44 times 0.4 is 0.576. The number 1 had a weight of 25%. So you take it squared, 0.04 times 0.25, and get 0.01. The next one times 20%, the next one times 5%, the next one times 10%. Excuse me. The point is, you're using the weights to find the variance now instead of adding those up, those squares, like last time. What we learned before finding the variance was on raw data with no weights. What we're learning now, the slight difference here, is if we have data with weights. The weights have to be involved in the variance calculation. Now, we add up those results. After we multiply each one of them with the weights, we add those results up, there's your variance. There's no dividing by n minus 1. Just add up those results after you multiply by the weights, and there's your variance. Take that variance, square root it, there's your standard deviation, just like before.
Could you go over it one more time?
Yep. We found the mean of this data because it has weights. We didn't just add them up and divide by 5. We multiplied each number by the weight to find the mean, called the expected value, 1.2. Now I'm going to subtract 1.2 by each piece of data. 0, 1 minus 1.2, 2 minus 1.2, 4 minus 1.2. And there's the result. Each piece of data minus that mean, and there's the result. Now I'm going to take those results and square each one to get rid of the negatives. Negative 1.2 squared, 1.44, and so on. Each number being squared. Just like before, we're right where we left off. Last time, when it was just data with no weight, we would have added these. But we're not adding these. Instead, we're multiplying each one of these, where my pointer's going up and down, by the corresponding weights. Times 0.4, times 0.25, times 0.2, and so on. Then we take those results and add them to get our variance. How's that? We add those results, we got our variance, square root it, you got your standard deviation.
Will the weights always be labeled as f of x?
So, it will be, I can't remember how I label them on a quiz. I kind of wing it and just put the weights next to it, probably with no label. But you'll see there's weights next to each piece of data.
Can you explain what the weights represent, like a practical, like a real example, what?
Yeah, this TV was a great example, actually. The weights represent, in the past, if I said to you, hang on a minute, let me go back right here. If I said to you, hey, tomorrow we're opening up, and we're gonna sell TVs. What's the probability we sell 2 TVs tomorrow? What do you see?
20%.
20%. Because in the past, out of the last 200 days, 40 of them we sold 2 TVs. 40 divided by 200 is 20%. So the weights represent the probability of the past repeating itself.
Okay.
So let's go one step farther. Look guys, we have to sell at least 2 TVs tomorrow. At least 2 TVs. No less. What's the probability we're gonna sell at least 2 TVs?
85%.
How much? I couldn't hear you.
85.
35? Yes.
35.
35. Is that what you said? At least 2 TVs would be 2 or more, right? So you gotta add up the 20% plus the 5 plus the 10%. 35%. Right? At least 2 TVs. Listen, we don't need to sell many TVs today. No, matter of fact, let's not sell no more than 2 TVs. No more than 2 TVs. Now what's that percent?
85.
85?
40, 50, 60, 85. You gotta add the 0, the 1, and the 2. The 40 plus the 25 plus 20. So those percentages represent historically what has happened and the probability of it repeating itself. That's basically what those are. Okay. Let's keep going.
Would we be responsible to get the weights?
No, you would be given the data and the weights. It would look just like this homework problem. Hang on, let me open that up again.
So this is gonna be on the quiz?
Right there, just like that. Here's the data, here's the weights. Just like that. And then it'll say, calculate the expected value, variance, and standard deviation from the following information manually. And you gotta show me your work, and there's the variance. I'm taking that 20.85 and subtracting each one of them by 20.85, then I'm squaring each result. And then I'm taking each square and multiply it by the 15%, the 45%, the 40%. Then I add them together, there's the variance, and then I square root it. Let's scroll down. Hang on. I square root it, there's the standard deviation of that data right there. These answers will be posted tonight, by the way.
This will be on the quiz.
Maybe. It could be. I only have, there's only gonna be like 8, 9, or 10 questions, so, you know. Maybe, you know. Some things will be there and some things won't, I don't know. I can't predict it. I haven't written it. All right, what do we wanna do next? I wanna remind you of a couple of mathematical things that are coming up that I wanna make sure you remember. You ready? Who's got a calculator? Put 25 to the exponent of 0. Or who already knows? What are you gonna get?
1.
Very good. What's 5 to the exponent of 0?
1.
Any number to the exponent of 0 is a 1. I can't tell you how many people forget this on a quiz. All right, let's go with factorial. 3 factorial is the same as 3 times 2 times 1, which equals 6. 5 factorial is the same as 5 times 4 times 3 times 2 times 1, which equals 120. Yeah, 60, yep, 120. All right, factorial means whatever number's being factorial, you multiply it times every number down to 1 below it. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's what factorial means. The reason I'm bringing this up because binomial probability has this formula. This x is the number you're being asked to find the probability of. X is the number you're being asked to find the probability of. And look at where it's at. It's in the denominator factorial. It's being subtracted from n, then factorial. It's the exponent with the p, and it's in part of the exponent with the 1 minus the p. X is all over the place. X is whatever you're being asked to find the probability of when we read an example here. N is, in the story, is the number of whatever items chosen at random. We're choosing this many at random. That's your N. What's the probability this many out of those chosen at random will do this? That's your X. So, I want to make sure and P is the given proportion in the story, the given percentage. There's going to be a probability or a percentage given in the story. Those are the only 3 numbers you need for binomial. Let me repeat them. The number being asked about, the number of items chosen at random, and the proportion or probability given in the story. Those are 3 numbers. And then you plug them into here and do algebra. Most of the points, a huge majority of the points, are in the setup. That you can take those 3 numbers and set this up correctly. There's a little bit of points showing the math, and a little bit of points getting the answer, but here's the big part of the points, is showing that setup. Excel equation is very similar. Equals B-I-N-O-M-D-I-S-T. Binomial distribution is kind of abbreviated, B-I-N-O-M-D-I-S-T. The first number is the x, the number being asked the probability of, just like it was x over there. The number being asked the probability of. The second number is however many were chosen at random, the n. The number of items chosen at random. That's the n, that's the second number. The third number is the given percentage or proportion in the story. Same with the p, right here. So the same 3 numbers, or the first 3 numbers over there in the parentheses, is the same 3 numbers in the equation here. But there's one additional number on Excel, either a 0 or a 1. With binomial, sometimes you're asked to find the probability of just one number. That means you put a 0 on the end. If you're being asked to find the probability of that number or less, or that number or more, either direction, more than one number, then you gotta put a 1 on the end. Let me repeat that. If you're being asked to find the probability of just one number, there's a 0 on the end. If you're being asked to find the probability of a number or less, or a number or more, which means there would be more than one number, you put a 1 on the end. Now you could use the word true and false. True would be at 1 and false would be at 0. I just happen to use the numbers instead of the words. That's all. It's up to you though. True is a 1 and the word false. If you want to type out the whole word false or the whole word true instead of a 0 or 1, you can do that, it will work as your last number.
Can you repeat the last part with the
Okay,
one or
the last number again?
With the last, yeah.
Yeah.
One or the 0.
1 or 0. If the question is asking about X all by itself, what's the probability there are two of these? Then you know to put a 0 at the end. But if the question says, what's the probability there'll be 2 or less? Or what's the probability there'll be 2 or more? You gotta put a 1 on the end in those two cases. Everybody hear that?
Can you show us some examples?
I am. You ready? Are you ready? Here we go. You're at this company. You're at this company. And this company usually has 10% turnover. 10% turnover. And that's kind of normal, a little bit, especially manufacturing company or something. About 10% turnover, especially if you have a lot of employees, maybe it's a little less. And then you're asked to choose 3 employees at random. And you're being asked, what will be the probability, calculate what the probability would be that one of those 3 employees will no longer be with the company in a year. We'll go 12 months and we'll look and see of those 3 employees, what's the probability one of them will no longer be there. Now, notice I didn't ask for 1 or less or 1 or more. I said 1 employee. Right now in Excel, I can tell you right now, what's this last number gonna be?
1.
Stop it. Let's do this again. Let's start all over.
Wait, what did you
There we go. Hang on. Why 0? The Y. That's right, because I'm only asking about what's the probability of 1. I didn't say 1 or less. I didn't say 1 or more. I just said 1. That's why we got to put a 0 on the end. 0. All right? Now look at this problem. This 1 minus in front of the binomial. I already got a 1 on the end because I know this is a more than question. And anytime if I would have said 1 or more, we would have put a 1 on the end. If I said 1 or less, we would have put a 1 on the end. But all I said, what's the probability that one of them will leave the company in a year? They're no longer with us. You get it? Okay, so now, let's set this up. What is my X? What number are you being asked to find the probability of? 1. Everywhere there's an X, I'm going to put a 1. What's the randomly chosen amount of items you were asked to choose? How many randomly chosen? 3. There's your N. N is the number you've been asked to randomly choose, which is 3. What's the given proportion or probability or percentage given in the story?
10%.
10% is your P. Those are the 3 numbers. Here we go. I'm going to follow that. N, you guys said was 3. 3 factorial over X factorial. That's 1 factorial, right? Let me make that a 1 so you can see. Parentheses. 3 minus 1, parentheses, factorial on the outside. There's 3 parts to this equation. There's the first part. The second part says use P, put it to the power of X. So I'm going to use, you got to put it as a decimal. 0.10 to the power of X, which is 1. The third part of this equation says to use the opposite of P, 1 minus P, parentheses, and put it to the power of N minus X. So I'm going to put this as 1 minus 0.10 to the power of 3 minus 1 exponent. There it is. That setup right there showing me you identified all 3 numbers and you knew where to put it in the formula are most of the points of that problem. I can tell you right now, 99.9% chance that you have a problem on there where you need to set this up. Show me that you can pull the 3 numbers out and set it up just like that.
And then you have to calculate to the end.
And then you got to calculate, but which are additional points. But this is where all the points are, right here. If you can do this right here, there's a ton of points. That's most of the points for that problem.
So I'm typing it in Excel and it's giving me an error message.
That's right. Hang on, let's finish this out.
Okay.
The first number, what did you put for the first number? It has to be what you're being asked to find the probability of.
3.
No. You're being asked to find the probability of 1. How many were chosen at random? How many were chosen at random? How many are chosen at random?
Three.
Three, that's your second number. What's the given proportion or probability in the problem? You have to make it into a decimal. I think you can use a percent symbol and it will read it, but I'm gonna use a decimal. 0.10, I don't have room for this front from zero, so I just put 0.10. There it is, there it is. This will get you the same answer right here, 1, 3, 0.10, 0. Because it's asking for exactly 1. I'm sorry, I skipped your question.
No, it's okay. I think you already answered it,
Oh.
because I was confused on how you get the 0.10, but I think 1/10 would be that, if that's how you got
Say that
it.
again,
The
where
10
did I
is
get this?
10% right there, the turnover.
Is that what you're saying?
Oh, that's where you,
That's the
okay.
10%.
Because the story said there's 10% turnover. You know what? I'm sorry, I should be showing this. Hang on, this will help. This will help. Here's the story. Evans is concerned about low retention rate for the employees. In recent years, management has seen a turnover of 10% of hourly employees annually. So it's given in the story. And then the story says, choose 3 employees at random. What's the probability of one of them leaving the company in the next 12 months? There's the story. You gotta pick out the ones you're being asked the probability of. The 3 is what you're, how many items you're choosing at random. And then the 10% is the given proportion or probability in the problem. Those are the 3 numbers you're trying to pick out of it to plug into this. All right? 3 factorial, let's do this real quick. 3 factorial is 6, right? 3 times 2 times 1. So I have 6 over 3 minus 1 is 2. 2 factorial is 2. 1 factorial is 1. 2 times 1 is 2. So there's that left-hand side. Times 0.10, because 10% to the power of 1 is 10%. Here's the tough one. This is 0.90 to the power of 2. Someone got a calculator, 0.9, 9 times 9 is 81, so would that be 0.81? 0.9 times 0.9.
0.81.
0.81 is it? So this would be 0.81. There it is. I showed the work. This turns into 3 times 0.10 times 0.81. You do the math on this, and it's right here. Here you go. Boom. 0.243. 0.243 is the probability of 1 out of 3 employees no longer being with us, chosen at random.
How did you got 0.9?
0.9, 1 minus 0.10. The opposite of 10% would be 90%. You gotta use the opposite of the probability given here. So let's, hang it, everybody help me out here. If the given probability is 20%, what would be the opposite? 80, 0.80. If the given probability is 30%, what would be the opposite? 0.7, 70%. Whatever the given probability is, you gotta use the opposite over here. Let's take 100% minus whatever's given. So,
So if it's 30, it'd be 60.
no, 100 minus 30 is 70. But you should get the point, I think. What if it's 15? I wanna make sure we're on it. 100% minus 15% leaves you, what's the opposite of 15%? 85%. She's almost with us. You almost with us? Help her after class.
It's 100 minus what you put on.
100 minus whatever the given percent is, or 1.0 minus the decimal.
So let's say you said 30%.
About factorial, okay, so there's a parentheses 3 minus 1
Are you asking about this?
No, at the bottom.
This one? Yeah, this says take however many were chosen at random, minus your being asked, the probability of the number you're being asked about, subtract first, then put it to a factorial. So 3 minus 1 is 2, 2 factorial is 2 times 1, which is 2, times 1 factorial, which is 1, so 2 times 1 is 2, that's where I got that 2.
How about the 6?
The 6, I got 3 factorial, which would be 3 times 2 times 1, so 3 times 2 is 6, 6 times 1 is 6, so that's where I got the 6. The 3 factorial. Yeah, factorials, you guys. Now, we only got about 7 minutes, and we gotta do more than. Go ahead.
I know in this example it wouldn't make any sense, but will we ever find ourselves with to the power of n minus x that turns out to be a negative x?
Never.
Okay.
Because you always are only asking about up to the amount that were chosen at random. So the most that could be is 3 out of 3, makes that a 0, which is why we reviewed this. Because sometimes this does end up, the lowest this gets is 0, and sometimes that happens.
Gotcha.
There's another question? Ready for the more then? Here's where it gets hard. Okay, everything was easy at this point, believe it or not. You ready?
Last question. Where's the 81 from?
What? Where's the 81 from?
Yeah.
I took this the opposite of 10% is 90%, and then I took 3 minus 1 squared, so I took 0.9 times 0.9. You got that. 0.9 times 0.9. So let me put an arrow. So all of this turned into this, which then turned into that. How's that? Let me make that point. Point there. Okay, here's the deal. I'm gonna ask this a different way now, starting with less than. Hey, this company usually has 10% turnover. You're choosing 3 employees at random. What's the probability one or less will no longer be with us in 12 months? 1 or less. Now look here. The numbers haven't changed. 10% turnover, randomly selected 3. I'm asking about 1 or less. The only difference is now this is a 1 on the end because you're asking about 1 or less. So you're asking about 0 out of 3. You're asking about 1 out of 3. If I were doing this manually and it was 1 or less, I want to make sure everybody hears this. I have to do this whole thing with a 1 for x, wherever the x was a 1. Then I get my answer, which was right there. I got to do the whole thing now, again, with x as a 0. 3 minus 0, right there. 10% to the power of 0. This is why we got to know the exponent of 0. 1 minus 0.10% to the exponent of 3 minus 0. There it is. And we have to calculate this all out. Let me get that 74 out of there, which was how long it took me to get here this morning, by the way, 74 minutes. And we need to calculate this out and get this answer, and we have to add it to that answer. Add. These two together represent 1 or less. When you're doing binomial probability manually, you're calculating it for one number at a time. And so for 1 or less, you got to calculate it for every number involved. If I said 1 or more, you'd have to calculate this for the number 1, do it again for the number 2, do it again for the number 3, and add those 3 together for 1 or more if I were doing it manually. So listen, here's my hint. If I'm asking you to do this manually on the quiz, I'm not going to ask for 1 or less or 1 or more. I'm only going to ask about one number because I only want to see this one time. If I'm asking you to do this Excel, it could be anything. Because one Excel equation does multiple manual equations. This one Excel equation is calculating the probability for 1, calculating the probability for 0, and adding it up for you because you put a 1 on the end here. It does both of them together.
And if we want to do 1 or more.
1 or more, hang on, this is my next thing. You ready? 1 or more now. 1 or more. I'd have to manually do this for 1, 2, 3, add all 3 results manually. Using Excel, 1 minus is in front for a more than. Equals 1 minus binomial distribution, parenthesis. Here we go. Here's the numbers. I know there's a 1 on the end because 1 or more. Now here's the weird part about binomial. This is where, this is, I can almost guarantee this on the quiz because this is the hardest question on the quiz. What numbers go in those parentheses for 1 or more? Here's the hint. In a more than question, the parentheses have to represent the opposite of what's being asked for. So if I'm asking for 1 or more, the parentheses have to represent 0 or less. If I were asking for 2 or more, the parentheses have to represent the opposite, which would be 1 or less. This question is all about 1 or more. What is the opposite of 1 or more? What number should be here, blank or less?
-1.
No.
0.
0. 0. How many were chosen at random?
3.
3. That doesn't change. What is the given percentage that was given in the story?
10%.
0.10. That hasn't changed, and a 1 on the end. All now this is for 1 or more. This is the hardest part. Okay, we've got 0 minutes left, so I'm going to give you one more or more. Ready? Hi, we usually have 10% turnover. We're choosing 3 employees at random. What's the probability 2 or more will no longer be with us in a year? 2 or more. Okay, let's do these numbers. 2 or more. Well, there's always a 1 on the end. And we know it's 10%. What's 2 or more? 1 minus in front. 2 or more. How many were chosen at random? At least give me that number.
3.
3. That doesn't change. But what is this number? What's the opposite of 2 or more?
1.
1 or less. 1 or less. That's the hardest part, is the more than using Excel. because the parentheses that are more than have to be the opposite of what's being asked for. If I would've said 3 or more, what would that first number be? What's the opposite of 3 or more? 2 or less, see, you'd put a 2 there. Get it? If I said 1 or more, what would be that? 0, the opposite would be 0 or less, you got it.
Would you just go down a number?
Just go down a number on the more than, but this is only with binomial and Poisson. We're not at Poisson yet. This does not, you would not do it like this with the other ones we're gonna learn other than Poisson. This is just a unique feature of binomial distribution because it uses discrete data instead of continuous. Normal distribution uses continuous data. Every question about this is either a more than or less than. There's never an exact. But with binomial, because it uses discrete data, 1, 2, 3, 4, without using the numbers in between, you gotta use the opposite of what's being asked for on a more than. Right here, then right here, go ahead.
If it's always more, like whether it's 1 or not, is there always a 1 in the front and then in the end?
If a more than, you always gotta have a one minus in the front and a 1 on the end.
Okay.
For a more than question, you gotta have those. Every time. You ready for the in class? Oh, I'm sorry, I forgot.
So to do it manually, you're only gonna ask us for the one exact.
Yeah, I'm not gonna say 1 or more or 1 or less, because I just wanna see this one time.
But for Excel, you'll ask.
Excel will probably be on 1 or more or 1 or a less than or a more than, yes. Because I wanna see that you can do all of this. All right, and I wanna see that you know to use this on the end.
If it's more or less, it will be, one of you.
You'll always, if it's a more than or a less than, there'll always be a 1 on the end for Excel, yes.
It's just like one number.
But it's just one number, so 0 on the end, and it will never be a 1 minus in front, because I'm just asking for one number, you're gonna use this equation with a 0 there. Okay, with the in-class assignment, this is totally preparing you for the quiz. I'm asking you just to set it up. I want you to set up the binomial equation, you pick the 3 numbers and set it up. I'm not asking you to solve it, set it up. And then the second the other question, I don't know which one's first, which one's second. The other one, I'm asking you to set it up using binomial distribution. I'm not even asking you to enter it into a spreadsheet and give me a result. I want to see the setup and the setup. One's manual, one's Excel. Are you ready?
Oh wait, are you giving us numbers?
It's coming right, yeah, you ready?
Oh.
You're gonna write down a piece of paper, set up both these problems. One is manual, one is Excel. Let's see. The first problem says, only give the Excel function equation only for this binomial problem. According to a recent survey, 64% of all adults are Facebook users. Consider a sample of 30 randomly selected US adults. What's the probability of exactly 18 or less are Facebook users? Uh-oh. Yeah, look at that. Get that word exactly out of there. Let me take that out. I should have got that. It's 18 or less. There we go, let me save. Boom. 18 or less. The second one says manually set it up. You're manually setting up. All right? It is reported that only 60% of Americans have confidence in U.S. banks. If 10 Americans are chosen at random, what's the probability that exactly 5 have confidence in U.S. banks? Exactly, because it's a manual one. If you notice, I'm using the word exact on purpose, so you're only doing this for one number. All right, good luck. I'm going to pass back the rest of these while you're working on it, because I'm not here to help. Don't forget, I'm not here.